All right, let's jump right in. We're going to talk about the hidden chemistry that connects, well, pretty much everything around you. I'm talking about solutions. And trust me, it's way more interesting than just salt dissolving in water. Okay, so what do the air you're breathing right now, a can of soda, and a brass key all have in common? I mean, a gas, a liquid, a solid, they couldn't be more different, right? Well, what if I told you that chemically speaking, they're all basically the same thing? Yep, the answer is they're all solutions. A solution at its core is a special kind of mixture. It's called a homogeneous mixture. That just means one substance, the solvent, dissolves so perfectly into another, the solvent, that you literally can't tell them apart anymore. It's not just stirring things together. This is happening at the molecular level, creating one single, uniform thing. So every single solution has these two main parts, the solute and the solvent. Think of it like this. The solute is the thing getting dissolved, like sugar. The solvent is the thing doing the dissolving, like water. And a super easy way to remember which is which, the solvent is almost always the one you have more of. It's a simple idea, but it's absolutely fundamental. Okay, so how can you tell if you're looking at a true solution? Well, there are a few dead giveaways. For one, the individual parts are totally invisible. You can't see the sugar in your coffee, right? Also, if you just leave it alone, nothing's going to settle out at the bottom. And you definitely can't separate it with something simple like a coffee filter. The whole thing is perfectly uniformly mixed. That's what makes it a solution. All right, this is where things get really cool. Most of us, when we hear solution, we immediately think of a liquid, right? But solutions can actually be gases, liquids, and solids. Let's get into this because it's pretty surprising. Let's circle back to that soda can. You know that psst sound when you open it and all those bubbles? That fizz is a perfect example of a solution. It's literally carbon dioxide gas that's been dissolved into the liquid. It's a gas in liquid solution, and it's probably the only one you can actually hear. And the brass key? You guessed it. It's also a solution. This one's a bit of a mind bender, though. It's a solid solution, what we call an alloy. What's happening is that you have zinc atoms completely dissolved and mixed in with copper atoms. It's a solid dissolved in another solid. How wild is that? Okay, now let's take a look at the whole picture. It turns out there are 9, count 'em, 9, possible types of solutions based on the states of matter. We've already hit on a few, like gas and liquid for soda. But check this out. Liquid in gas? That's just plain old humidity, water dissolved in the air. Or what about gas in a solid? Some high-tech systems actually store hydrogen fuel this way by dissolving it right into a solid metal. And even a solid in a gas, that's how an air freshener works. Its molecules are literally dissolving into the air. Once you see it this way, you start to see these combinations everywhere. Okay, so we've got the states of matter down, but there's another way we can categorize solutions, and that's by asking how much stuff is dissolved in there. This, my friends, is all about concentration. Let's imagine you're making a cup of tea. At first, you add a spoonful of sugar and poof, it dissolves instantly. That's an unsaturated solution. You can definitely add more. So you keep going, spoon after spoon, until you see sugar piling up at the bottom. Now you've hit the limit. It's a saturated solution. It can't hold any more sugar. But what if you heat it up? Suddenly, you can dissolve even more sugar. And if you cool it down very, very carefully, you get this really unstable thing called a supersaturated solution. It's holding way more sugar than it should be, just waiting for something to disturb it. Now, on a more everyday level, we usually just talk about things being dilute or concentrated. And coffee is the perfect example. That weak, kind of watery cup of coffee, that's a dilute solution. Not much coffee stuff, lots of water. But that intense little shot of espresso, that's a concentrated solution. A whole lot of coffee packed into a tiny bit of water. All right, we're on to our last big category. This one is super straightforward, and it's all about what the solvent is. And in chemistry, this is a really big deal. It all boils down to one simple question. Is the solvent water? If the answer is yes, you've got yourself an aqueous solution. Salt water, our blood, you name it, they're aqueous and absolutely critical for life on Earth. If the solvent is literally anything else, alcohol, turpentine, whatever, it's a non-aqueous solution. You see these a lot in industrial settings, where water just isn't the right tool for the job. So with all these different combinations of gases, liquids, and solids, how do you know what you're going to end up with? Well, there's a really simple rule of thumb to remember. The state of the solvent pretty much always determines the state of the final solution. So, if your solvent is a liquid, your solution is going to be a liquid. If it's a solid, you get a solid solution. Simple as that. The solvent is the boss. So there you have it. From the very air we breathe to the metal alloys in our buildings, solutions are just everywhere. They're the invisible chemistry holding our world together. So now that you know the rules, I'm curious, what's the most surprising solution you can think of that you run into every day?